Okay, so we're here in Prusa Slicer. We're about to create some G code that would be appropriate for our concrete mixer. So I've created various print settings, filament settings, and printer settings that would be appropriate. So if you look at the print settings, you can see we've got one here called concrete printer. Which if you edit that, we can see the layer height is set to about 1.5 centimeters, and the first layer height we're going to make it a little bit lower, about 10 centimeters, and the rest of them we really don't have to worry about that. We're not going to be doing any infill or skirt or brims or anything on this either, so we'll just keep those as said. For the filament settings, well, it's going to be a 10 millimeter filament, I suppose, but it really doesn't matter. We are extruding concrete in this case, so we don't have to worry about that too much. And in the printer settings, we're going to make the bed quite large. So we're going to make the bed 1,000 millimeters or by 1,000 millimeters, or about a meter by a meter, which would be enough to hold our big pots. And we're going to make the maximum height about 1.2 meters. So we have huge um, bed size, bed volume, which is great. Now we're going to go over here, and I've created three little pots. So I'm going to start with a cylindrical pot, which we'll drag on over there. There's a nice cylindrical planter pot we'd like to print. Um, and we have the concrete printer settings all in place, ready to go. So let's just slice that and see what we get. All right, looks like we got very bold, very bold print right here. Nice thick lines. And the base looks like it's ready to go too. So I think our cylindrical pot looks great. So let's just export that G code, and we'll save it as cylinder pot G code. Tuck that away. Now we can just delete this one. And I'm going to go back to my files, and we're going to put in the square pot. Okay, there's a beautiful square pot. We're going to slice that one too and check it out. That looks very nice. All right, beautifully sliced. So we're going to export that G code, call it a square pot, save that away. And I'll go back to the model and we'll delete that again. And now let's get the last custom pot, and built that in Fusion. And there's the triangular pot. Now, the triangular pot looks like it's going to be a little bit large, so we don't want to use that one as is. But I can take it, and let's see if we can resize it so it fits on our platter. Yeah, it looks good. It's going to be a fine pot. So we'll slice that one now and check it out. Very nice. We will export this G code and save that. And now if we look at our files, we can see we have the cylinder pot, the square pot, and the triangle pot G code all loaded up and ready for us to 3D print. All right, I just wanted to go through the process of setting up your system and printing out a few different kinds of pots that I've created earlier in a Fusion 360, and then I sliced them up in Prusa Slicer in the previous little talk. But let's say we're going to load up our 6700 V1 right now. So there's our robot. I even backed on a controller beside it, scale, I suppose. Now, at this point, we want to go to our 3D printing app, and we're going to start. We're going to go generate the G code. So let's just choose a pot for our first sample. So we've inputted the pot, and we have to, if we can't see it here, so let's see, we're going to have to import it already. So let's go ahead and press import. Okay, and the pot looks like it's in a great spot. The work object frame is right. I don't think we're going to have to change that at all. So let's go ahead now. And we don't have to worry about the print position because it seems to be pretty good. Path tune, again, I think I'm going to make it just the default. Target offset, we'll choose aligned with robot because that's going to make it much easier to set up. And if I look at the target here, this is the tool center point for our extruder, and they line up quite nicely with the all the targets on our pots. So I'm really happy that they're going to have no problem lining up. If they do have a problem at this point, we would rotate. We would do changes to the rotation of all the targets to try to make them line up. But I don't think we'll have to in this case. Next, we'll check reach. Got a few configurations here. This one's got a very large angle on it, so I'll try to avoid that one. This one's got a large angle too. And this last one here, all the angles look like they're quite good. So we'll just apply that. And the robot went through all those motions and felt that there's no problems at all. It was able to reach all the spots. So we were good. All right, so now that we have the targets set up and we can check the reach, we're not doing external axes yet. And for the process, we'll choose the externally controlled extrusion with an optimal cycle time, which means it's gonna print it as quickly as it optimally can. We should be all right. So now at this point, we're gonna go export. We're gonna export it to Rapid, and we're gonna call it hot. And then I'll put the date behind that, March 18th. And this is the cylinder pot. So we'll just export that. Very good. And now it should be good to go. So now let's go to Rapid, and we'll synchronize everything, and hopefully we'll be ready to go. So I'm going to go back to my 3DP, and we'll turn on process trace. We'll enable the trace so we can see our pot forming. And we'll go ahead and, we should probably set the program pointer to main, and all tasks. There we go. If I go back to Rapid and check out the Rapid code, there's my Rob1 main 3DP, and the program pointer is right there. And we have a couple of these move absolute joints. This moves the robot to a certain joint position, but doesn't worry about any paths or anything to get there. It just moves the joints to those positions. This is useful if we want to move through complicated motions where the robot may twist itself past an axis or perhaps reach a singularity. These usually get away from. But that being said, this might not be the position we actually need for our robot to be in. This is the actual position it's going to reach into. Now we're going to try it, and let's see if it actually works. So we're going to click on here. No guarantees at this point. Press play. And right now the robot's processing all of the layers. In a moment, it's going to reach down again, and we're going to see if it can do it without any uncomfortable postures. So just wait here for a moment more. Okay, now she's going in, and it starts to print. So I can go to 3DP, and maybe we'll speed that up a little bit so it's a bit faster. And while it's printing, let me just show you a few things. So these are all the station elements on here. This is the default task. Here is all of our tool data, the nozzle tools held right in here. This is our work objects. There are work objects, the joint targets for when it initialized. There is the work object palette, which we can see right down there that it's actually printing on. That's the work object palette. And these are all the paths that were created by the 3DB program. There's the main entry point right here, where it does the two moves. There's the main 3DP program. And these are the post layer events. So this is what happens after a layer is printed. Anything in here happens before, and so on and so forth. So these are all the paths and targets. Now, if we go to rapid, we can actually see the true code. So here, this is the TROB1, the main 3DP. You can see this is the actual program running. And if we had any issues with these instructions, that would be the problem with the license for the 3DP. These are all the events. So the init events, this is what's going to happen during initialization. There's the post part event and the pre-part event, which happens before you print the part, and what you do after you print the part. And this is the post queue event and all those kind of things. So if you have to do anything between the different layers, you can just put your instructions into these areas and it would do them. Okay. This is the robot export list. You can see all the robots, all the parts that we've been printing all show up right here on this list. And this is the main 3DP program that you can see that calls the 3D print routine. So now you can see the part's been finished and has disappeared. So that looks like it's ready to go. So now at this point, you would go back to your controller and you would create a relation between the virtual robot and your real robot. Then you would copy from the virtual to the real robot all of the files, and then you should be able to run it on the real robot at that point.